Welcome back to another TrueNAS Tech Talk. 24.10.1 is out. We're going to bust a couple myths about ZFS today. We'll run a year in review of TrueNAS and the updates it's had, and give you a little sneak peek at what's coming in 2025, is my understanding, Chris.
Yeah, absolutely. It's going to be a good show. We get to do some fun stuff. It's Christmas. It's the holidays. Let's have some fun with it.
Yeah, I was going to say, I love that you're endorsing a fantastic Christmas movie on your shirt there. I can see the edge of it.
Yes, best office party ever.
Die Hard is a Christmas movie. We're taking 100%. A stance on that.
Yep.
Yeah. Just before we dig in here, another quick programming update. We will be taking next week off to enjoy our holidays, maybe get some Boxing Day shopping in if we're going to be building any new NAS systems ourselves. But we will be back on January 3rd. So make sure you subscribe to the TrueNAS Tech Talk podcast and ring that notification bell so that you'll catch our next episode as soon as we're back.
Man, we're going to start saying 2025 now, too. I'm going to get that wrong the first few episodes. So forgiveness in advance, everybody. I think
it'll be probably a month for me. I'll be saying 2024, and don't worry, you're not experiencing a time loop. It will be the next year. It's just me.
It's all good. It's me too. Okay, so let's talk about the big release that happened this week. So Tuesday, 24.10.1, which is the first point release of the Electric Eel series, just went out the door. We had a couple minor hotfix releases we did previously, but this is the first kind of big point release where there's 100 plus, issues, bugs fixed, a whole bunch of good things. Looking at the numbers, we had about 15,000 upgrades in the first 3 days. So
that's a new
big
record, isn't it?
That is a new record. So that was big. That's good to see. Happy to see that many people were upgrading. We've had a handful of users report some difficulties with various app configurations, but so far we haven't seen anything kind of systemic across the whole fleet. So one thing I'm going to mention, I think, Chris, you'll comment on it as well, is bug tickets help us figure things out. So we need the tickets to come in so we can determine if there's some commonality between some of these issues or if there's anything systemic we have to address.
Yeah, absolutely.
Just don't assume the other guy's going to do it. Send it in yourself, please, because
a
lot of times we find out it is somebody has a really esoteric use case or set a weird knob that we hadn't looked at recently, and we need to go check it.
Absolutely. Like, send in those tickets, send in those debug files. The little smiley face icon in the top of your TrueNAS UI makes it really easy to just click that button. You log into our Jira instance and you'll be able to check off a box that just says send a debug in with it. Put some description about what you're doing, maybe a little bit of ideas about what your system's got in it. Because even just talking with other folks in the community, I have a very similar hardware setup in some of my test machines to those who are having problems, and mine's working. So when somebody says, hey, you don't have support for the NVIDIA Tesla P4 GPU and it's not working for transcode, I look over at my system in the corner and say, well, mine's working. I want to see what one of us has done different. Either I've done something different to make it work, or you've done something different that's making it not work. So please, send in those tickets, send in those debugs. We'll be able to track down and see what the difference is. And especially for those sporadic issues, Chris, you know that the intermittent ones are the most fun to troubleshoot. So the more data points we get, the easier it is for us to draw those correlations and, get marks on the graph that say, okay, everybody who had a fault has this same configuration. Let's drill into that.
Well, and I'll just kind of go on a little bit of a rant here too, but this is part of the process when you have kind of software define anything. Everyone has so many different hardware configurations out there. People build their own systems. It's different if you have a product. If you guys were all buying the exact same TrueNAS Mini and it only came in one flavor, that's super easy for us to test and confirm certain things work, and there's only so many knobs. But when literally you have hundreds of thousands of people out there building all different hardware configurations and then slapping TrueNAS on top of it, it makes it a bit challenging. Even two systems with the same build, they may have put the cards in a different order, and that could trigger something. I mean, it's software. This is what happens. But all that to say, you have to send us the details and data, because if we're not seeing something in our labs, and if other community members are saying, no, it works fine for me, we have to go then and puzzle out, like, what's slightly different in your case. Is it a different knob you clicked? Did you run a command that's a little different? Is the hardware slightly different? Oh, I'm running a different BIOS version, and it has this issue, and I need to update. Like, we've seen it all. I've seen it all over a decade plus of doing this. So again, details matter. So the more details, the better.
Yeah, those of you who have the systems with heterogeneous cores, you have P cores and E cores. I mean, I'm sure you all noticed on 24.10.1, you said, hey, where'd my thread counters on the dashboard go? We switched to counting physical cores instead of virtual threads. But some of you who have the mixed processors with P's and E's, things disappeared. And, send us your bug trackers, send us your debugs. And if we notice that there's a commonality, we'll be able to say, hey, what was it querying on there and how did it get it wrong? Maybe we'll be able to teach that dashboard how to deal with those cores and get that in an upcoming hotfix.
Yeah, that's not something, we don't have any products we offer, so there's not much testing in our lab of those kind of CPUs. But again, that's what you guys are here for. And again, please send us debugs and info. We're happy to take a look, but we just need the collateral to go and make good decisions, because it is kind of hard to write bug fixes in a vacuum when you don't have access to things yourself to test. So
absolutely.
Do your developers a favor in the new year. Send in tickets, please.
Thanks. Thank you in advance, everybody.
Chris, you have a little bit of a Mythbuster segment for us. What are we going to get into today? Let's bust some TrueNAS myths.
Yeah. So, we talked a little bit about caching and the log behavior on, I think it was episode 5, where we made the Wu-Tang joke. But I keep seeing this come in, and that's probably because we have lots and lots of new users constantly coming into TrueNAS. Our user community is growing every single day. So it's worth just restating for everybody who is new what those caches are good for, and especially the log side. Lots of people are saying, hey, if I want my TrueNAS system to go faster, I'm going to add a log device for write caching. And again, I said this in the last one, it actually isn't a write cache, it's a write log. And the difference is it's more about the safety and security than it is about speed. So your asynchronous writes, so if you don't have a log device and you have very fast writes over like SMB from Windows or a iSCSI ZVol that you haven't forced synchronous on, those writes are already as fast as they can go. You are doing your transaction gathering and aggregation up in RAM. RAM is way faster than any solid state drive that's out there. So turning on those synchronous writes where you need them, if you're doing transactional databases, if you're doing VM hosting, that is about improving your safety and saying, hey, when my client system writes something to TrueNAS, it needs to land on that non-volatile storage. So even if the second or the millisecond after that write finishes, you lose power, or your HBA or your power supply or your motherboard decides that's the day it's going to give up the ghost for good, the data is still safe on disk. Adding in the log device is about getting back that lost speed when you turned on synchronous writes. Because even if you were synchronous writing to the fastest SSD in the world, you still have to write it to 2 places. So adding that log device is about getting back the lost speed. It's not going to get you going any faster than if you started. So if you somehow found an SSD that is literally as fast as RAM, putting that in there is going to get you back to that asynchronous write speed. It's not going to make you go any faster. So just make sure that when you're looking at adding a log device, you say, am I actually going to benefit from this? And with the expectation of, I'm never going to go faster than with asynchronous writes or with sync equals disabled or sync equals standard in the case of things like SMB. You'll never get going faster than that, but you'll get going fast safely. That's what it's about.
You hinted at it, but I think most of the use cases for this are folks doing block, is where we traditionally see this get turned on and deployed, is people doing VM backing, where you need synchronous writes. That guest VM, that file system needs to know when it thinks it's flushed something to disk, it actually has landed on disk and isn't going to disappear if power or network or something gets disrupted at the absolute worst possible time.
Exactly. And that's a big thing with iSCSI, especially because iSCSI sometimes will rely on your destination storage system to enforce that. That's why you turn on sync always for iSCSI. A lot of NFS clients and some hypervisors, whether it's VMware or XCP or KVM, their NFS clients will say, well, we're going to enforce sync from our side. So sometimes people say, hey, iSCSI is way, way faster than NFS. Well, make sure that you're comparing iSCSI with sync equals always to NFS, because that's your true apples to apples there. If you're running iSCSI without sync equals always, you do have a bit of that data risk, as Chris mentioned. That data could be potentially lost in the case of a sudden system crash at the very wrong time. So be safe when you're doing your ZFS.
Okay. I think you had another rule we were going to get into too. There's a lot of new users who don't understand ZFS, so I'm totally cool when I get it.
Yeah. And those who are using logs, sometimes they say, well, how big does my log device have to be? We mentioned it before in that the log device sizing of the physical device is basically driven by how fast you want it to go. Bigger devices have more NAND channels. They might have faster controllers, more DRAM for caching. Typically, a larger device goes faster. But most users are not going to use more than 4 gigabytes by default of their log device. You can increase this. There are tunables to do that. And maybe we'll bring up some information on the screen and links down in the description to information about how that can be done. But increasing that amount of pending data, whether it's in memory, on your log device, both, it does eat into the memory that's used for that adaptive replacement cache, so your read and metadata caching, as well as it leaves your data pending longer, especially if you're using asynchronous writes. In general, when you're making changes like this, the rule is to, you go low and you move slow. Make those changes, observe how it changes the performance of your system, and then, make them in small iterative chunks. Most of these knobs can be tuned live while the system's running. So if you have a, perpetual benchmark that you've got going, you can just slowly change the knob on the back end and say, hey, did this change things? Okay, was it a positive or a negative direction? Don't just take what somebody else has written for the tuning their system and assume it applies to yours. Do your own experimentation, do your own research, and, make sure that you're actually getting the results you want and you're not putting yourself at unnecessary risk.
Yeah, this is part of the power and the complexity of TrueNAS, right? If some people get a little overwhelmed, TrueNAS is very enterprise in the sense that we give you a lot of knobs. It's like the first time you peek into the cockpit of an airplane, if you've flown before and you're like, oh my God, look at all these different knobs. But you need those because those do things, those matter. It's not as simple as just driving your car down the street. TrueNAS is the same way. We set good defaults, and defaults are just that, though. They're defaults. It doesn't mean it's optimized for your particular workload. A lot of different workloads have a lot of different things they could potentially leverage to make them faster, more reliable. So it's important to understand what kind of workload you're going to throw at it. Yeah, maybe 90% of the time, the defaults are great. Good. More power to you. You didn't have to touch anything. If you got a more esoteric use case or you're doing something, very specific and you want to squeeze out that extra 10 to 15% of performance, this is where it pays, to go take some time and learn a little bit and pay attention to the details where the details matter.
Yeah. Hey, speaking of percentages, that's another good one that we like to hear that a lot, where people talk about there's an 80% rule or something that applies to ZFS where you shouldn't fill it more than 80% or horrible things will happen. And that, again, it's one of those things that it's been ingrained maybe in the history of ZFS where people have said it over and over. And it's, some people think it's become a truth, and it's still much more complicated than that. So the idea of this 80% or this free space rule is that because ZFS is a copy unwrite file system, it's always trying to write into free space. So the more free space you have, the easier it is for that ZFS storage pool allocator to say, hey, I've found some empty space to write into. Imagine like when you're moving between houses, if you only take what you need, you bring all the boxes there and you only unpack what you're using at the given time, well, your new house is going to stay really, really clean up until you need all the things. Now, imagine if you had several identical houses next to each other, you owned all of them in a row. And instead of cleaning a house, you could just say, well, I'm going to take what I want over to the new one. And then magically behind the scenes, somebody's going to clean up after you. That's kind of what ZFS is doing with that copy on write behavior. You're saying, oh, I'm going to move house. Okay, my last one's getting cleaned. The more space you have, the easier it is to be able to just find that space to write to. So sometimes for block storage, people say, hey, I want to keep half my pool free. So that if they said, I'm going to, overwrite everything that I have on here, well, ZFS will still have a big chunk of empty free space to write to every time. It's a media dependent thing too. So people who are running on an all solid state system is going to be less impacted, because even when they're having to seek around to find that free space, well, there's no seek penalty on a solid state drive. All of your LBAs have the same distance from each other. If you're using spinning drives, you might be a little bit more impacted. But again, it's going to be dependent on your workload too. If you're writing a bunch of media files or you're doing, data hoarding, shout out to the data hoarder guys. We appreciate you. Maybe you don't have to worry as much about it because you're writing in big sequential workloads and, you're never deleting anything. By the time you start to get out close to a threshold of being full, you're already out there buying more drives. You're attaching another JBOD because, data addiction is a real thing.
That we encourage that here, by the way.
Absolutely.
It's a good addiction.
Absolutely.
It's one of the few.
Yeah, we, there may or may not be JBODs coming for Christmas.
That's right.
Yeah,
that's right. That's pretty obvious under the tree, though. I think.
It's hard to hide that one, and they're a little bit heavy. But the one thing is about free space is getting 100% full. If you 100% fill a file system, that's always a bad situation, no matter what you're running. So just make sure that you do pay attention to those alerts, especially when you get past 80. If you're pushing the boundaries there and you get to 90 or even 95%, pay attention to that one. Maybe do a little bit of housekeeping, or maybe it's time to order that next JBOD and a whole rack of drives.
Well, I'll throw a little freebie out especially for some of the new users. You may get into the situation where you're going to go delete some things to save some space. And this happens all the time. And I see it on the forums all the time. Hey, I deleted a bunch of things on my SMB share, but none of my space came back. What happened? Go check your snapshots. Please go check your snapshots. Snapshots will not let you, it basically is holding a copy of that data until you remove the snapshot. So you have to delete the snapshots before the space starts getting reclaimed.
Yeah. But those snapshots are really helpful if you accidentally deleted something you want back. It's much better to have it go that way, to say, hey, I need to take an extra step to make sure I deleted something, than go, well, now I've deleted it and I can't get it back.
Yeah, it's gone forever, right?
Yeah.
But anyway, take a look at that. Again, that's something people tend to trip up on the first time. So we've all been there, though. No
Absolutely.
Okay. Well, thank you, Chris. Appreciate that. So let's do a little bit of a recap of the year and take a look ahead at 2025. So first of all, it was a big year in growth. We had over 25%, I think a little more than that, in total number of TrueNAS systems we saw deployed. Again, the real number could be higher, lots of air gap systems that don't show up in any of our usage numbers, and that's fine. That's cool. But either way, big number. That's a large chunk of growth this year. Also, Scale became the predominant version being run in the wild. I think that crossover happened, I want to say, October-ish timeframe, it was late October.
Yep. I think there was a big version of TrueNAS that released in October.
Something
we had a couple big features that people were really looking forward to, and I bet that drove some of that adoption.
I was going to say, it was, thank you, Docker. That was all electric eel. A lot of people jumped over at that point, and that's when the crossover happened. So again, that was a great thing to see over the year. We're really excited for that. And another number we don't talk about a whole lot is exabytes. We added another 2 exabytes of storage under TrueNAS management over the course of the year. That's incredible. That's a lot of space when you think about it. So again, congrats to everybody. All you data hoarders, keep pumping those numbers up. Those are rookie numbers. We can do better.
We can do better than that. Yeah. That's a lot of Linux ISOs, guys.
I wonder how many. Now I'm getting sidetracked. How many ISOs are there, and what would it take to store them all over the history of all the Linux distros? I'm sure it's a lot, but maybe not 2 exabytes worth. Anywho, okay. So now that 2410's out, Electric Eel, that's been out for a while, and of course the dot release has landed. But let's talk ahead a little bit here. 2504 is the next release, Fangtooth. And so it's kind of weird for me talking about this because we've been working on this now for months in the background. The development for that began, some of it back in September even. So we're well into it in this case. Some features have already started landing, features in the nightly images people can play with now. For example, the new 6.12 kernel's landed. I've already seen some folks testing that because it's got new hardware support for fancier new onboard GPUs and ARC and all that good stuff. So that's exciting. Dashboard's got some love. There's some nice little app widgets there now where you can show your app and what's going on and see kind of usage and all that. That's fun. Another big one is the containerization support has started landing in the nightly UI. And we'll actually get into a demo of that here in a second. That'll be a little treat for the end of the year. But that's LXC and Incus backed containers have started landing. And obviously we're still working on it. There's a lot more polish to do. We got some more features that are going to be landing around that. But still fun, exciting times. And if you have time over the holiday and want to try out a nightly, we appreciate users giving us feedback and telling us what's working and not. And just those early impressions are great because this is the time when we can make changes. We're knee deep into the development. It's always harder after you get into RC cycle. It's like, well, we can't make that change now because it's too risky. It might break other things. That's not the time to do it.
Feedback and tickets, crucially, as we mentioned before. Feedback, tickets, and debugs.
Absolutely. And then, of course, at the end of the year, we talked about the renaming of the product, too. You'll hear more about that in 2025. I think the website's already been updated in quite a few places, but we're dropping the core and scale monikers. Those are going away. Instead, we're going to more universally just refer to things as TrueNAS and either the Community Edition or Enterprise Edition, depending on if you're running our products or enterprise gear, of course, just as a way of differentiating. So some of the verbiage will change, and that's a good change as well. I think we're all ready to embrace that here, especially on the IX side. That'll just simplify our lives going forward. And with that, I think we're going to go ahead and do a demo here, Chris. This is going to be fun. We haven't done a demo on the podcast yet, so knock on wood, this goes well. But let me go ahead and share. Let's do a
absolutely. Yeah. For those of you who are listening as audio only, we do apologize. Chris is doing a screen share, so please join us over on the YouTube to see the video of this happening live.
Absolutely. Okay. So I've got my nightly image. This is an image from the other day. So I want to say the 18th of December is what this image is from. You'll see there's a new little containers work in progress tab in the UI here. And when you bring it up, this is where LXC containers are currently living. So what does this look like? Today in the UI, it's pretty straightforward. If you've done other things in TrueNAS, you'll recognize a lot of it, the same workflow. We're going to go ahead and create a Debian image though. But while we're here, this is actually kind of fun. People kind of, their jaws drop a little the first time they see this. They're like, wait, what are all these different Linuxes I can install? Yeah, there's a lot. There's a lot.
Oh, and there's a filter on the left, so that's really beneficial for everybody who's looking for that.
You want your NixOS? Yes, NixOS is here.
Oh, open
Oracle Linux. I don't know why, but there's Oracle Linux. But in this case, although I did play around with OpenSUSE, I haven't done that in a decade. That was a trip. I felt like such a novice. I was like, I don't even know how to do anything here anymore. It's changed so much over the years. But let's go ahead and we'll try and set up a Debian bullseye here real quick. We'll give it 2 CPUs. We'll give it 4 gigs of memory. And if you look, it'll change it. Yay. Thank you. Let's see. I set it to auto start. Good. I'm not going to use the default network settings. I'm going to use Mac VLAN. And why is that important? Well, I'll show you here in a second after I go ahead and create. So just a moment here. There we go. That created. It was nice.
There was no skip there. That was real time.
Oh, that was real time. Now, granted, I did do this beforehand, so the files were cached. But the first time I did it, it still only took like 10 seconds. I have a 2 gig network connection that downloaded the image quite fast. So it was very snappy. But as you can see here, the container is now already spun up and running. I can bring up the shell. And for all intents and purposes, I'm now in a new Debian environment. I can run apt update. And I mentioned the Mac VLAN. Let's talk about that for a second. You'll notice I got this IP address. That's on my local subnet. That's one of the things Mac VLAN will do is just out of box, you're going to get DHCP working. So my container was able to reach out, get an address. But additionally, that means if I want to do static, I can now go configure that inside the container and do it via the normal means for whatever Linux distro I'm running. So that's kind of cool. But everything's all working. I can let's install OpenSSH. There we go. You can see everything's very snappy here. So it's pretty neat. Now, if I go back here under Debian, one of the cool things is because it's a container, you can mount storage in. So I could go through and I could mount some storage from the host directly into the container, and that takes place immediately. You don't even have to restart. It's quite nice. I think I had that set up on my Ubuntu here, for example. I have a location on my disk already mounted inside the container, and I use that for testing, which is pretty cool. Yeah. But anyway, this is, again, an early peek, subject to change. We're still working on it. I already have a small list of things I want to see improved and kind of cleaned up going forward, but the bones are there. It's starting to take shape, and we're excited to get this into people's hands here. I mean, beta is still only a few months out. We're talking February, I think, towards the end. So we have a little time, but you're going to see this continue to get polished. And additionally, there's going to be some support for VMs coming in soon. So without further ado, I'll stop sharing and let's talk about that a little bit, if you don't mind. So let's talk about, first of all, again, a lot of new users, maybe some of this technology is new and different and people haven't done their homework or really played with these yet. So I want to do a little bit of a high-level explainer what the difference is between, say, an LXC container and Docker containers, which are all the rage in electric eel. So Docker, you can think of it this way, and I'm going to try, again, forgive me if this is oversimplified, but I'm going to do my best. So it's designed to be a way to ship a particular app or a particular set of apps, a configuration, with the ability to throw things away and do easy updates where the data that is persistent is very centralized. So for example, in a Docker container, typically you would map in storage under /data or /opt, or containers may have different locations. But the point is the container itself, the contents of that container can all be thrown away. And as long as that one persistent directory stays persistent, you can upgrade. You can, every time you restart, it's technically recreating everything.
Yeah, you have your config stored separately from it, and everything else, the apps itself, just they get flushed away. You get the new version. It grabs its previous config file and says, all right, I'm back.
All right.
That was it.
That works particularly well for apps that do have a central database or a central location for storing their configuration. Where that doesn't work, and maybe you've noticed this if you've ever logged into a shell of a Docker container, is if you go, muck around in the etc directory, for example, because you want to change some setting, and then restart your container, you notice those changes don't persist. They get blown away because, again, etc is part of the image, and that's all predefined by the container creators upstream. So this is where LXC containers come into play. LXC is a little bit more like a traditional FreeBSD jail for those who are coming from that ecosystem. What that basically means is think of it as a VM, but a very lightweight VM. So it's the whole OS minus the kernel. In this case, when you're running an LXC container, you're still using the TrueNAS host kernel, but everything else after that, userland, is all its own dedicated instance. That's why I'm able to get its own IP addresses. It has its own networking stack. It has its own app, catalogs, its own location on disk. So basically everything minus, loading kernel modules and doing kind of kernel level things can be done inside the container. So what are the advantages of that? Well, first of all, as I mentioned, compared to Docker, it means everything's editable. So you can log into it. You can, in the example, I was setting up OpenSSH. That's what a lot of people might do on the very first go around is you set up SSH and you log into it like it's a VM. You SSH in, change your IP address around, change config, change things in Etsy, systemd commands, blah, blah, blah. All that persists now.
You can run apt in a container. That's the key difference, is that you can run apt all you like. If there's some piece of software you want to set up that you'd say normally, oh, I want to put this straight on TrueNAS. Well, now you can quickly make a container with it, run your apt install, your apt upgrades or updates in there. Just do whatever you like in the container and be confident that you're not going to do anything to the TrueNAS install underneath.
Absolutely. And because the containers are lightweight, they're a lot more scalable. You can, typically you can see somebody, at scale, say they're doing thousands of containers on a system versus, VMs, it might be tens, maybe 100 in some extreme cases. But because it's a much lighter weight virtualization, the resource constraints are a lot better. Additionally, speed is super important. The container has access to the underlying storage at native speeds. This is through using bind mounts, or if you're from FreeBSD land, the equivalent is nullfs mounts. You don't have to go over a sharing protocol over TCP like SMB or NFS, which you do if you're in a VM. You have to find some way to map storage in, and because you're going over a protocol, there's some performance impact to that, of course. When you're doing a bind mount, that's pretty much as fast as you can go without being directly on the host. The speed difference is negligible. I don't even think it's measurable in most cases. So that's huge. If you want to pass through underlying storage to any of these containers, LXC containers is the way to go. And of course, CPU and memory requirements are far less as well, because you're not running a whole nother kernel with its own, virtual memory to manage and all that good stuff.
You don't have to emulate a bunch of hardware just to get your system up and running.
Correct. So when would you want to use this? Well, I think in most cases, if you're ever going to be running Linuxy things on top of a TrueNAS box, you would run the LXC container. That's the better, it's the more efficient, it's the cleaner, safer way to do it. Now, granted, there may be some exceptions to that. You may have to run a Linux VM that needs some kernel module or something that isn't available on the TrueNAS host. Okay, that's when you fall back to a VM.
Yeah.
Or you use a VM in the case of running some non-Linux OS, Windows or BSD would be the two examples, obviously. Or if you're an OpenBSD guy, that's where you throw OpenBSD in a VM. Cool. That's obviously a different kernel and is not going to run through the kind of lightweight LXC interface. But that's kind of in a nutshell. Hopefully I explained that all. Did I miss anything obvious, Chris?
No, I think we got the good parts there. It sounds like there's a lot really exciting that we'll be looking forward to in 2025. And so people will probably be very interested in that Fangtooth beta when it's dropping, hopefully in February.
Absolutely. And the one thing I'll mention is if you're running the nightlies and are adventurous and going to experiment a bit with us, please do. We enjoy having all the feedback. The support for running VMs inside of this new infrastructure is going to be landing soon as well. So the demo I just showed, for example, you'll have options to say, I want Debian, but I want to click a box and have it actually go into a VM now, as opposed to an LXC container. It's going to be that simple. And of course, all the options for uploading an ISO and all that good stuff if you want to do a non-Linux based VM. So stay tuned. I'm sure we'll cover that in future episodes as some of that work begins to land. I'm expecting some of that in January and of course, before we get to the beta in February. But exciting times ahead. I'm looking forward to next year. There's a lot of good stuff happening. I know it seems like Electric Eel just launched and it's only been a few months, but man, future's looking good. We don't really take our foot off the gas here.
Absolutely. There are no brakes on the TrueNAS train.
That is right. Man,
right.
That was good. Good end of year, everyone. It's been a fantastic 2024 and looking forward to 2025 with y'all.
Yeah. Well, thanks for the recap, the preview there, Chris. It's been really fantastic. I've really enjoyed doing the podcast with you this year and looking forward to more in the next. So Thanks again, everybody, for tuning into T3 this week. As always, feel free to submit your questions to t3@truenas.com. Drop us a message in the comments section below. Kris and I do try to get in there to reply, but we don't manage to get them all. So please don't think we're leaving you out on purpose. Don't forget to like the video, subscribe so that you don't miss the next episode when we come back. And we'll see you next year.
Excellent. Looking forward to it all. Thanks.